Hey everybody, the problem that I chose to break down is 7.4, number 4. I chose this one because it threw me off on a couple of places and took me longer than I anticipated to solve it. So I thought it would be good practice for me to do it again. So here we go. So if we take a look at this, we can see that the form x squared minus 1 is already in the form of c squared minus b squared in the Pythagorean theorem. So that's good. That means that we're set up. So what we're going to do is draw the triangle. And if we pretend that this triangle is on the unit circle, then C, which is the hypotenuse, is also R, the radius, so that'll be X. And then we're going to choose to make B the X-axis, so we'll make that 1. And then that makes the opposite angle, or the Y-axis, will be the square root of x squared minus 1. Now we're choosing 1 for the x-axis because it makes it really easy to make x equal to secant. So right now we'll define what x is. So we're going to say x is equal to secant of theta over 1, or really just secant of theta. And that's because secant of theta is r over x, right? The radius over x on the unit circle. So that means delta x is going to be equal to the derivative of the secant of theta, which is secant theta tangent theta, delta theta. And then we also need to define this square root of x squared minus 1. Now the book has you do it, and the word problems have you do it in a different way. I just like to kind of do the visual way. So we know that this is the y-axis, right? And then this is the x-axis, and we know that y over x is equal to tangent. And so x squared minus 1, the square root of x squared minus 1 over 1 would be equal to tangent. So we have the square root of x squared minus 1 squared, right? Technically it's x squared minus 1 squared is equal to tangent theta. So we'll go ahead and rewrite this using these new values. So we got delta x, we know, is equal to secant theta times the tangent of theta, delta theta. And we have the x squared minus 1. So remember, 3/2 actually means square root to the third power. So we know the square root of x squared minus 1 is tangent, so we'll just say tangent to the third power. Theta. Tangent to the third power theta. Okay, so now we need to figure out what these values translate to for x. So we know that x is equal to secant theta. So when x is 2, we're going to do it over here, save some room. We'll put 2 equal to the secant of theta, which means that the inverse secant of 2 is equal to theta, which is equal to pi over 3. And we'll do the same thing for the higher value 4. So we'll say 4 equals the secant of theta, which means that theta is going to be equal to the inverse secant of 4. Now this doesn't come out to a nice fraction, so we're just going to leave this way because otherwise we'll have to write it as a decimal, and then that stops it becomes less accurate when we convert to decimal early. Okay, so we got the lower value is pi over 3, and the upper value is the inverse secant of 4. So now really what we need to do is simplify these terms. So we know that we can cross out tangent here and cross out one of the tangents here and make it tangent squared. So we'll just rewrite that now. And we're going to leave out these guys for now. So we got secant theta over tan squared theta delta theta. Now at this point we kind of need to rewrite this in terms of sine and cosine. So remember that the secant theta over the tangent of theta is equal to 1 over the cosine of theta divided by the sine squared theta over the cosine squared theta, which equals the cosine squared theta over sine squared theta times cosine theta. And that's going to simplify to cosine theta over sine squared theta. Now here is where I got confused, because I thought that this needed to be converted. We know that 1 over sine squared theta becomes cosecant theta, right? And then cosine over sine theta becomes cotangent. So I thought that we'd end up writing this as cotangent times cosecant theta. But what we need to remember, cotangent theta, is that never in this class yet have we used those identities in these types of problems. So if you just use logic, they're not going to throw this at you out of nowhere, hopefully, right? So there's probably another way to solve it that is within the bounds of what we've been learning. And that's what I needed to understand. So anyhow, so we know we originally had secant theta over tan squared theta. It breaks down to cosine theta over sine squared theta. So we're going to rewrite this now in those terms. You know, our lower bound's pi over 3. The upper bound is the inverse secant of 4. And we're going to write that as cosine theta over sine squared theta. Apologize for my handwriting. Delta theta. So what we're going to do is use u substitution now to kind of finish this out. So we're going to let u equal sine theta. And it makes delta u really easy because delta, the derivative of sine theta is cosine theta, equals cosine theta delta theta. So now those are all the terms that we're using here, so we can just swap these out, and then we'll have to find new values in terms of u for the upper and lower limits. So we'll do that in a second. So first we'll rewrite this. So cosine theta delta theta becomes delta u, and sine squared theta becomes u squared. So it's going to be 1 over u squared times delta u. So now for the lower and upper bounds. So we know that u equals sine theta. So what we're saying is for the lower bounds, pi over 3, we are saying that theta is pi over 3. So then sine of theta is equal to u. So the sine of pi over 3 is equal to the square root of 3 over 2. A nice fraction. And for the upper bounds, right? So equals u, right? So for the upper bounds, we have this inverse secant of 4. So we know that u is equal to the sine of theta. Theta is the inverse secant of 4. So u is going to be equal to the sine of the inverse secant of 4, which actually comes out to a nice fraction, equals the square root of 15 over 4. Which is equal to u. So on the lower bound, we have a square root of 3 over 2. In the upper bound, we have the square root of 15 over 4. So now all we need to do is find the antiderivative of 1 over u squared, delta u, and then plug these values in and solve. So 1 over u squared is going to be equal to, so 1 over u squared is equal to u to the negative 2. So it's going to end up being u to the negative 2 plus 1, which is negative 1, over negative 1, which is also can be written as 1 over u, negative 1 over u. So it's negative 1 over u is the antiderivative, with the lower of the square root of 3 over 2, the upper square root of 15 over 4. So now we just need to solve this and plug these values in. So we're going to have the negative 1 divided by square root of 15 over 4 plus, right, because it's negative 1, and this is normally a minus, so it's minus a negative equals a positive, equals adding. So plus 1 over square root of 3 over 2. So we can rewrite this. 1 over a fraction is equal to the opposite of that fraction. So we're going to say negative 4 over square root of 15 plus 2 over the square root of 3. Whoops. Over the square root of 3. So now we need to rationalize the denominators because we have radicals in the denominator. So we're going to multiply these by their denominator. So we'll do that here. So we're going to multiply negative 4 over the square root of 15, multiply it by the square root of 15 over the square root of 15. Which is actually a fancy way of saying 1. I'm sure you've seen this in other problems. And then it's going to be plus 2 over the square root of 3 times the square root of 3 over the square root of 3. And our final answer is going to be negative 4 over 15, right? Square root of 15 and square root of 15 equals 15 times the square root of 15 plus 2 over 3 times the square root of 3. And that is our answer. Thank you for watching.